So the recording has started. You can start, sir.
Okay, thank you. So good evening, everyone, and I thank Dr. Barada for giving me another 3-day session, and also very glad to see you again, the participants. This topic we are going to go for a couple of agenda, and these are the agenda for the next 3 days. We'll be discussing about correlation, when to conduct,
Yes.
how to conduct.
Yeah.
And
I have
what
a
do you mean by-
seminar, bro.
So we'll be discussing what do you mean by correlation, and then what purpose, what conditions we can run, and what are the assumptions. With 1 or 2 examples, we are going to use SPSS to analyze the data and interpret the results. Bivariate, partial correlation, simple linear regression for today's session. Tomorrow, we'll be discussing about multiple regression and logistic regressions, the purpose, assumptions, 1 or 2 examples. We carry on with SPSS, then followed by interpretations, how to write them in a research paper. So 3rd day, I'll be covering exploratory factor analysis and cluster analysis using SPSS, their applications, and how to run using SPSS and interpretation. Okay. So we move on with today's session, correlation coefficient. And first, I think the 2nd day also, the previous last week, I have covered a little bit about the correlation coefficient. And there are number of couple of correlation coefficients we can run: parametric Pearson correlation, non-parametric Spearman, and the Kendall's. So we move on with what is correlation, by the way, in definition. Correlation actually is nothing but it's a statistic that indicate the strength and direction of the relationship between 2 variables. Strength and direction of the 2 variables. Whether the variables are positively related or negatively related. If yes, how strong the 2 variables are related. Will provide a single numerical value. We call them as a Pearson correlation coefficient in parametric. Single numerical value to represent the relationship between the 2 variables. So the numeric, the correlation coefficient ranges from -1 to +1. Suppose after analysis, your correlation coefficient, the numeric, if you get close to 1, you get perfect direct relationship. We need to write perfect direct relationship, meaning both the variables are very perfect linearly related. Suppose if you get your R value, the correlation coefficient equal to 0, indicates there is no such relationship observed between the 2 variables. When you get a correlation coefficient -1 or close to -1, we need to write, or we can infer that the correlation between the 2 variables are perfect inverse relationship, meaning one variable increases, other variable decreases. Otherwise, your X variable increases, the Y variable decreases. Your age increases, some attribute decreases. Height increases, body weight increases. This is called perfect positive relationship. Okay. So this is the properties of the correlation coefficient. So there are different types of correlation coefficient. One in parametric Pearson product movement correlation coefficient. We used to write R italicized. So this Pearson correlation coefficient used to assess the relationship between 2 normally distributed continuous variable. Continuous variable means the scales of measurement can be ratio or interval scale, parametric data. So Pearson correlation is the most widely used correlation statistic to measure the degree of relationship between linearly related continuous variable. Continuous variable means it can be your height, it can be your weight. So height and weight, advertisement versus sales, your age versus systolic blood pressure, age versus cholesterol, income versus your expenditure, right? Number of years of experience versus your income in a private sector, right? So these all can be related, how these variables are related. So next one is Spearman rank correlation and Kendall rank correlation. They all comes under non-parametric. We call them as a rho. Spearman rank or the correlation coefficient. When we can use it to assess the relationship between two continuous variable in which any one of the variable is not normally distributed. The data does not follow normal distribution. We need to go for a non-parametric Spearman rank correlation. Otherwise, you have one numeric variable, another variable is an ordinal variable. This scenario, you can go for Spearman rank order correlation. The similar condition applies to Kendall's also. Similar conditions. Kendall, for example, if both the variables are ordinal, straightforward, you can go for a Kendall. Kendall rank correlation coefficient. Used to assess the relationship between two ordinal variables, or one ordinal, one continuous variable, non-parametric. We have to go for Kendall's rank correlation. So this is the objective we need to write if you are going to go for it. Writing your methodology. So Kendall correlation coefficient was used to analyze the relationship between the study variables. This is my independent variable. This is my dependent variable. We need to spell out. Any doubts so far? Participant, do you have any clarifications before we move on to the next topic, next slide?
Sir, is there any number required for this variables? Where we can apply for this?
Not compulsory, sir. Not compulsory for this kind of number. Usually anything more than 10 also, the system will give you the answer. 10 paired observations. 10 paired observations. If you look at any textbook, you usually go for small numbers. But in research, minimum 30 is recommended, sir. Minimum 30. You will get good relationship. Minimum 30.
Okay, sir.
But there is no such standard for Pearson correlation, sir. There are some factor analysis. Factor analysis, there is a limitation. There is a sample size is a matter. Sample size is a matter. Okay. So what are the assumptions? Your two variables should be measured at the interval or ratio scale for conducting Pearson correlation. Interval scale, ratio scale. Can you all please recall what do you mean by interval? What do you mean by ratio scale? Ratio scale means the starting point is 0, ending with infinite. Interval scale, the variable will also have 0 value and also negative value. Interval scale. Negative value also will give you the meaning. 0 also will give you the real meaning, the property of the data variable. So assumption number 2, there is a linear relationship should be present, the two variables. So we can assess the relationship by scatter plot. We can assess the relationship by whether positively related, whether is there any relationship, we can assess by qualitatively by graphical illustration. Even Excel and SPSS do the purpose, serve the purpose. So assumption number 3, there should be no significant outliers. What do you mean by outlier? Unusual value, unusual data. Outlier can be possible by typo error, or maybe mistakenly you enter the data, or by nature it may have it. So as a researcher, you need to decide whether to include the outlier or not. Outlier is nothing but in a research study, one value or few values are away from the rest of the observation. Unusual value, otherwise, unusual values. Outlier, extreme value in a study. So that may infer, that may affect your analysis. So there should be no significant outlier and your variable should be approximately normally distributed. So this is outlier. Imagine that a couple of value x variable and y variable are related, presented in a scatter plot, but one value which is very far away from the rest of the observations. All other variables or all other data points in a linear fashion, but only one data points far away from the rest of the observations. So this can be considered as an outlier. So as a researcher, you need to spell out. As a researcher, sometimes it may be a real data, but you need to justify. Sometimes maybe by unusually you may type, instead of 11, you may type 111. Instead of 11, you may type mistakenly 111. So in that condition, you can remove those data. So example. So one researcher conducted a study. He recruited untrained individual from the general population to study about the relationship between a person height, how well they are related with a long jump performance in a sports science data. Person's height, whether it is related with a performance in long jump. Is it related? So what the researcher did the study? Untrained individual from the general population. They measured their height, and then they asked them to perform a long jump. How much the distance each candidate they jump. So then they investigated whether is there any relationship between the height and long jump performance. Height influences the long jump performance. The height otherwise is advantageous for them to have long jump performance. Okay, so I'm going to take this example for analyzing the data for Pearson correlation and help you to interpret the correlation, understand the concept of correlation. So what we need to do in correlation? We need to enter the data in 2 columns. In the variable view, 2 row, whereas in the column data view, we need to enter the data in 2 columns. Height in 1 column, long jump in another column. So once you have entered the data, we need to go to analyze, then correlate by variate. In this window, you need to transfer your height and weight X and Y variable from left side to the right side, like this. Please, we need to check the Pearson correlation. Click OK. Click OK. Then you will get the output. Participant, I have sent you these slides, sent you the handout manual to you also for your reference. I have sent you the manual around 176 slides, PPT slides. I have sent you in a PDF file. When you download it, it will be there in the last PDF file. Please make sure. So once you click OK, your output will be ready. So simple table. So we need to look at the intersection of the 2 variables. This is X variable, this is Y variable. This is X variable, this is Y variable, height in meters and long jump performance. So this is actually is the Pearson correlation. The next one actually is the p-value. And this third row is actually number of candidate, number of observation, the data were collected. Number of candidate, number of individual, the data were collected. So there are 27 paired data. 27 individual, the data were collected. So R equal to Pearson correlation, R equal to 0.884. So what do we infer? What do we infer? So reporting the results, a Pearson product moment correlation was conducted to determine the relationship between individual height and their long jump performance, the distance they jumped. The results reveal that there is a strong positive correlation observed between height and the long jump performance, which is statistically significant. Then we need to write Pearson correlation R equal to 0.884, comma, the number of observation N equal to 27, P less than 0.0001. Even less than 1% level of significance also, the study is showing statistically significant evidence. Is that fine? Is that fine? Shall we go to the exercise and then run? Shall we go to the exercise and run? Participant?
Yes, sir. Yes, sir.
Yes.
Please go to the folder. The file name 1.2. The file name 1.2. So there are 27 paired data. Maybe you can also look at in the variable view. Height has been given in meters and then long jump performance. Long jump performance also in meters. So let us say height in x-axis and long jump performance in y-axis.
So file number, sir? Sorry.
1.2 Pearson correlation, sir. 1.2
Okay.
Pearson correlation. Height versus long jump distance. Shall we go for it? I hope everybody might
Yes,
have opened it.
sir.
Yes,
So
sir.
before we move on, let us try whether the data showing any kind of relationship by a scatter plot. Go to graph, click on chart builder, click on chart builder. In this window, can you please see there is a 6th one, scatter plot, scatter or dot plot.
Sir, bit slow, sir. It's opening, sir. Just give me half minute, sir.
Okay. Okay, sir. Okay, sir. Yeah. Once you are done, then let me know, sir. I'll wait for it.
Okay, sir. Okay.
Yeah.
Yeah, okay, sir. I opened. Now I start.
Have you all opened it?
From
Have
where?
you all opened it? Yeah. Variable
Yes, sir.
view, we have two row, two variable. In the data view, we have two column. So this is our variable. Height in given in one variable, one column,
Yes.
and long jump distance has been given in another column. So we are going to see visually by conducting a scatter plot. Then we move on with Pearson correlation. So click on graph, chart builder. In this chart builder window, from your bottom side, left side, the gallery, please select scatter. Please select scatter. And then using your mouse, left mouse, just press the first graph, drag and leave it into this empty place, a white space or the panel. Have you all done it? Just simply drag and leave it in the panel.
Sir, repeat again, sir. Graph, chart builder. Okay.
No, graph,
do you have this
chart
window,
builder
sir?
and scatter plot.
Yeah, in this gallery, you have a favorite, bar, line, area, bi and polar, bipolar. The next one is a scatter, sir.
Okay, okay.
Just click using your left mouse, and then you have a couple of scatter, the simple scatter, the first one. So using your mouse, just click, drag and leave it in this white space. Just leave it. Drag and leave it.
Yes.
And then now we can transfer our variable x-axis and y-axis. So height, using your mouse, you drag and leave it in this x-axis, that particular box, x-axis box. So when you select, it will be red in color. And then long jump, you drag and leave it in this y-axis carefully. That's it. That's it.
Yes, sir.
Yes.
So once you are done it, just click OK. Just click OK. You will see kind of how the values are displayed. Just click OK. Please tell me whether you all got the scatter plot.
Yes, sir. And
Sir.
it is approximately linear.
Approximately linear. That is enough, sir. That is enough. So that will give you, is there any relationship, and also will give you positive relationship or negative relationship approximately.
Yeah, positive.
Positive relationship.
Positive.
So graphically we come to know, is there any relationship? If there is no relationship, we no need to run the correlation. Do you agree with me? If there
Yes,
is no
sir.
relationship qualitatively in the graph, no need to go for what you call scatter plot. Sorry, Pearson correlation statistically analyzing. So it looks like positively related, but we do not know how strong they are related. We do not know how
Yes.
strong related. So for that, we need to go for a statistical analysis, Pearson correlation. So before we move on, I also repeat, even last class also I explained how to conduct a normality, the same data. At least this particular one exercise I'll repeat, then we move on. After scatter plot, we also run the scatter plot, what you call the normality testing. Shall we run the normality testing, the same data?
Yes, sir.
So please remember that testing of normality, there are two approaches can be conducted. One is a statistical approach, another one is a graphical approach. Graphical approach, there are many, like a histogram, QQ plot, detrended plot, box plot, etc. Whereas in the statistical approach, we can go for a skewness and correction. We can go for what you call Kolmogorov and Shapiro-Wilk test. Okay, so just be run, and then I will demonstrate how to interpret. Go to analyze, click descriptive statistics.
Then explore.
Yeah, then click explore. Fantastic, sir. Remember, very good. Descriptive explore. So in that, we can transfer from your two variable from left side to the right side, dependent. From left side to the right side. And then click statistics. By default, descriptive statistics has been chosen. Fantastic. Fantastic. So if you are interested to look at outlier also possible. Just you can also click outlier, percentiles also. Let us see what is that. Descriptive, outlier and percentile also you can check and continue. At least we have some idea. Then plot.
Histogram and normality.
Histogram and normality plot with the statistical test. Great, sir. Very good. Histogram and normality plot with statistical test. Continue. Click option. What is the option? We no need to have anything. Just continue. Yes. And then give it to OK. So what I did, I have transferred. In statistics, I checked descriptive by default has been chosen, and outlier, percentiles, continue. And in the plot, I have chosen histogram and normality plot with statistical test. Continue. SPSS will give you a lot of data for us to infer whether the variables are normally distributed. There are several approaches, but you know, it's not compulsory to keep all your output in your thesis. Maybe 1 or 2 sentences we can capture from the analysis. Maybe for a PhD thesis, you can include any one of the graphical or statistical approach. You can keep it in your appendix. You can spell out. So the data were tested for normality using SPSS, using histogram or Shapiro-Wilk test or Kolmogorov test. Or I have followed based on the skewness and kurtosis. Or I have followed box plot. The results are given in appendix. That's it. And the data were followed normal distribution. Hence, I used Pearson correlation. Okay. Just click OK. So in your output, SPSS will give you a lot of info. It shows that there are 21. There is no missing. Look at here, height in meters and long jump performance. The skewness value, anything from -1 to +1. The skewness value and kurtosis value, anything -1 to +1 consider. -1 to +1 consider the data were normally distributed. Normally means bell-shaped distribution. Bell-shaped distribution. Your mean, median, mode will be in the center in a normal distribution. So the skewness and kurtosis value, it express anything between -1 to +1. The variable consider normally distributed. Well and good. The average has been given.
Sir, either of these two, either skewness or kurtosis or both.
Anyone can be used, sir. Anyone can be used.
Okay, because sir, in height in meters, skewness is from positive to positive.
Okay.
But kurtosis is from negative to positive.
Okay, sir. But these are in the benchmark value, range of values, -1 to +1, sir. Like a Pearson correlation coefficient. The skewness value, anything between -1 to +1, your assumption has been fulfilled, valid. Your data shows that normally distributed. Agree?
Yes, sir.
We don't need to worry about it. You can show the skewness value. The skewness value was found to be this to this, this to this. The results show that within the range, normally distributed. All right. And then the system also, while selecting the extreme value, highest value, lowest value also been given for us to have some idea. Look at here the what you call test of normality. So testing for normality, how do you state null hypothesis and alternate hypothesis? Testing for normality, how do you state null hypothesis? The values are normally distributed. The values are normally distributed. This is what our null hypothesis. Null hypothesis.
Yes.
But alternate hypothesis, the values are not normally
distributed.
Not normally distributed. So look at the significance value.
Yeah, both null hypotheses are accepted.
Null hypothesis are accepted, meaning p-value which are greater than 0.05, it show that the values are normally distributed. The p-value greater than 0.05 do not have evidence to reject the null hypothesis.
Yes.
So the values are normally distributed. One approach. Another one, height in meters. Histogram. Histogram. Just a double click on the graph. Just double click on the graph chart editor. Just lay the show distribution curve. Lay the distribution curve. it shows that the bell-shaped distribution. The shape of the curve looks like a bell-shaped distribution, like a temple bell. The line not touching the x-axis. This is for height. And then you have for QQ plot, all the data points are overlaid linearly on the trend line. And then QQ plot, 50% of the observation approximately above the median line and 50% of the observation below the line, approximately. Well and good. And box plot, approximately the box are in the center, not slightly the lower side, but it looks like in the center, approximately. And this is for long jump. You can also double click and put the histogram show on the curve. This is also normally distributed. So long jump performance also, all the data points are what you call arranged on the linear line, normal QQ plot. This is one evidence. This is another approach, detrended normal QQ plots. 50% of the data points above the median line and 50% approximately below that. Not exactly 50-50, close to 50. And sir, this is a box plot.
Excuse me, sir. While
so
writing on a paper,
are in the center.
Sir,
yeah.
Can I? Sir, while writing a paper, then should we show these different options, or we can simply write in the data are data follow normal distribution?
Okay,
that
yes,
is
sir.
enough.
That's enough, sir. That's enough. Actually, you can write the Kolmogorov-Shapirow-Wilk test. The data were tested the normality using Kolmogorov and Shapirow-Wilk test. The results show that the values are normally distributed. That's it, sir. One sentence is enough for a research paper.
Okay.
One sentence is enough. Otherwise, if you are more interested, you also can spell out the skewness value. The skewness value also you can spell out, sir.
Yes, sir.
Okay, the values were normally distributed. The skewness equal to this, kurtosis is equal to this. You can proceed.
Or can we write, sir, QQ plot shows
also
the
can, sir.
normal.
Also can, nothing wrong in that. Anything can be written, sir. But we need to spell out.
Yes,
you need to spell out. Suppose if you don't spell out, you say that normally distributed. What test you used it? So we have to be very transparent, very clear in writing a research manuscript.
Sir, if we write a normal curve is utilized to show the normality, then do we need to show the curve?
Not mandatory, sir. Not compulsory for a research paper. Research paper, when you go for publication, the space is a limitation.
Yes, sir.
But the journal, they look for your significant results, not for this kind of evidences. But the data should have fulfilled the assumption. But they don't expect all the evidences. But nowadays, I see that some journal, they expect your what you call supporting document, wherein you can attach. Nothing wrong in that. Will not be displayed in the paper, but they document it.
Sir.
Supplementary documents.
Yes, sir.
Supplementary files. Your raw data can be kept. Some quality journals. Nowadays, they ask for it. Even all your Excel data file need to be given.
Sir,
your questionnaire need to be given. Sometimes they ask. Some journals, especially Scopus Index journal.
One more question, sir. Please. Suppose mischievously I write that data are normal. Then is there any such option without getting the data? Is there any such option that to check whether the data are normal or not?
I didn't get your point, sir. Without?
Suppose in the journal we don't provide we don't supply the data.
Okay.
But and while verifying, we see that the data they do not follow the normality. But in the paper, we intentionally we want to write yes, data follows normality. So is there any such provision to check whether this means from my point, whatever I write on the paper, is there any such provision to check whether the data are not normal?
By looking at your journal data, sir, cannot. Looking at the journal, no one can find out whether your data, whatever you say, yes. But they may also look at, for example, if you go for any kind of graphical illustration, sir, I'll come back to you one more thing.
Sir.
When you go for any graphical illustration, maybe your variation is too much, your error bar is too much, then there is a chance. then there is
Yes,
a
sir.
chance. So it shows that there is a huge variation. They may look at when your standard deviation value, when it is very, very high, then there is a
Yes, sir.
possibility your data may not be. For example, sir, I will change one value here. I'll change 2, 3 value here, the last 2 values. Okay, so maybe
Yes.
I'll change it for 4.45. I'll change it for 5. 8.5. Suppose.
Yes,
Now
sir.
you rerun, sir. Now you rerun. Otherwise, I'll demonstrate a graph. Go to graph, chart builder. Go for a bar. Sorry, first reset. I changed only the 2 value.
Yeah, go for a scatter plot. Bar. Okay.
This time we have for a bar chart, sir. So display error bar, standard deviation, standard deviation of 1. So I have changed a couple of value purposely. So because of that, the error value may be longer. See here, height in meters, the error is very, very small, whereas a long jump, the bar is very, very high. So it shows that there is a huge variation. Then they may ask, when you present this kind of graph in the results, they may ask you, did you check whether the data is normally distributed? You have used a parametric statistical test. Did you check the what you call normality testing?
Yes.
Based on this error, they may ask. But however, this one is where the observations are very, very closer. Agree, sir?
Yes, sir.
Okay.
Yes,
So,
yes, sir.
from this graph, they may ask the
sir,
question. They may ask you.
Yeah,
Yes, sir.
thank you, sir.
Yeah.
Sir, one basic question, sir.
Please, sir.
Yeah, sir. What is the significance of this plotting, this QQ plot why we are plotting this QQ plot?
All
What
graphs are meant for
Maybe.
testing for normality, sir. All the graphs are testing for it is all inbuilt application in SPSS to show there are several approaches are used to show the data normally distributed, but it is not compulsory to show all your what you call output. Any one of them can be used, sir. Any one of the graphical illustration or QQ plot, a box plot, histogram, or skewness kurtosis value, any one can be used to justify your data is normally distributed. Your data is valid for parametric statistical test. For that reason, system is giving you various approaches, evidences to show your data. But you can use any one of them. It's not compulsory to show all the evidences. Agree, sir?
Okay. Okay.
Okay. Okay.
Thank you.
So participant, please tell me what was the original value? What was the original value? Yeah, it is that. Okay. So this is our original data. Participant, can you hear me?
Yes, sir.
Oh, some error is there. Yeah, okay. So please double check the last 2 value I modified. Now it is a 2.38, 2.65. Shall we run the Pearson correlation? Shall we run? Go to analyze.
Sir.
Correlate. Bivariate. Correlate. Bivariate. Very, very simple, sir. Only thing is you need to know how to key in the data in SPSS. You need to remember how to key in the data for a given statistical test. Pearson correlation means in a 2 column, X in one column, Y in another column, X variable, Y variable. T-test, ANOVA, there is a different way to key in the data. So that is very, very important. Each statistical software, their requirements key in the data are vary. So you have to have practice. You need to remember the way you key in the data. Otherwise, you end up with what you call failure in data analysis. The system will give you some kind of error messages, will not allow you to complete the data analysis. Okay, So using your mouse, by pressing the shift key, you select the two variable. By pressing on the middle arrow from left side to right side, you change it. And then by default, can you please see here? There are three types of correlation I mentioned: Pearson, Kendall, and Spearman. The data is fulfill the normal distribution. So Pearson comes under parametric approach. Parametric Pearson correlation coefficient, it comes under parametric statistical test. The data fulfill the normality. We tested using various approaches. That's it. Click OK. You don't need to do any changes. You don't need to do any changes. Maybe you are interested. You can also look for means and standard deviation to explain your data. Maybe you can explain means and standard deviation. Continue in the option. Click OK. Please tell me whether you have all got the output.
Yes, sir.
So look at here, height, the average is 1.74. There are 27 candidates. The standard deviation is 0.09. Long jump performance 2.61 plus or minus the standard deviation of 0.180, n equal to 27. Look at the Pearson correlation, height versus the long jump. It comes with a double star. It shows that significantly, statistically, R equal to 0.884. The p-value less than 0.05. N equal to 27. The results show that height and long jump performance are significantly, linearly strong relationship observed. So both the variables are highly significantly related. So height increases, the long jump performance also significantly is increased. So in a simple layman, we can write language, you can write your result section. So I have given you how to write them in the result section. So product movement Pearson correlation was conducted to determine the relationship between the height of the candidate versus the weight of, long jump performance, the distance they jumped. The results revealed that there was a strong positive linear correlation observed between the height of the candidate versus the distance they jumped, statistically significant. Then you need to spell out this. Even you no need to present the table also. You don't need to present. Only you can capture this and present. Enough. You don't need to highlight the table, present in your thesis. Just one sentence is enough. Is that okay?
Okay, sir.
Okay. Shall we move on to the next exercise?
Sir, one more question I want to ask. So you have written P less than 0.001.
Yeah. Why I have written? See the p-value.
Yes, sir.
So negligible, sir. The chances of having the results is very, very less. Chances of having,
yes, it is written correlation is significant at 1%.
Yeah, 1% level. Even 1% level.
Yes,
meaning
sir.
Having the results is very, very highly significant.
So since it is 1%, so we could have written p-value is less than 0.01.
0.001 also writes. You can write, sir. 1%.
But no, sir. 0.001. Then it will be 0.1%, sir.
Okay. Otherwise, what do you do, sir? You can also write p equal to 0.00030. You can write 0.000. You can write p equal to.
Sir, p less than 0.01, sir.
Also write, sir. Also you can write, sir. Nothing wrong in that.
Yes, sir.
Yeah.
Otherwise, sir, it will be a very less level of significance, sir.
So having the results due to chance is very, very limited. Very, very less.
Yes,
very
sir.
Negligible, sir. So your results is the results finding is very good. When your p-value is less, you have significant results. So chances of having the results due to probability is very, 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 very negligible.
Yes.
Agree. So when you have very less p-value. P is nothing but the probability of having the results due to chance.
Yes, sir.
Chance is very less. So this is due to your x and y variable. This is due to the results is due to height and long jump performance. Agree?
Yes, sir.
Okay. So please go to the next exercise. Maybe we can also run one more exercise. You can go to 1.4, make it faster. you can practice with, and someone can tell me how to interpret. 1.4, just click correlation regression, advertisement and sales.
Sir, same thing.
Values are normally distributed. Yeah, please
Yes,
open
sir.
the file. You run the analysis and tell me the answer.
Graph and then
Go to
chart
graph
builder.
also can. Graph also can.
Yes.
Chart
builder.
Chart builder.
Yeah.
Advertisement in the x-axis. Sales in the
Y-axis.
y-axis. Just click OK. You will have some idea, rough idea. It looks like advertisement increases, sales volume
positive.
also increasing.
Positive
Relationship. So we can run the correlation. Go to analyze, correlate,
Yes.
bivariate.
Descriptive should I see?
Say again, sir.
Descriptive part.
You can also mention, sir. You can mention average, the mean and standard deviation you can capture in the thesis or in the paper. You can mention. So correlate, bivariate. You select advertisement and sales from left side to the right side. Option, you can click means and the standard deviation. Continue and OK. Please tell me anyone. Please tell me anyone, how do you write and how do you write the inference interpretation? Can you all see my screen? Have you all got the same results?
There is a strong correlation between advertising, spending, and sales.
Fantastic,
Yes.
fantastic.
Yes.
R equal to 0.916.
91.6% correlation.
Fantastic.
And
Fantastic.
24.
Yeah, fantastic, sir. So n equal to 24, p less than 0.01. So highly significant. So can you please see here, if you have doubt, can you please see at the bottom? That is inference, double star equal to, double star meaning the correlation is significant at 0.01.
1%. Yeah,
1%
level.
So this inference you can take it for writing your inference. So this table also you can highlight. This table also you can highlight. So otherwise what do? You copy these two table, copy this, go to one Excel file. Open an Excel file. Copy this. Open an Excel file. Give me 2 minutes. So I'll demonstrate how you can capture the values all in. So copy the table, first table, and open an Excel file. But learning this correlation coefficient using SPSS very, very easy. But using Excel also we can fantastic, very well you can run. Using Excel also you can run. So once you have opened an Excel file, you can format your output here. Once you open an Excel file, just you paste it here. Then you write R value here. R value. And then you write P value. R value 0.916. P less than 0.001. Agreed, sir? Is that fine? So
yes, sir.
we do not need this many decimals. You can reduce the decimal by click on this. So you can format your data. This is your variable. That's it. You can format your table. Arrange your table like this. This is enough. You can merge this. You can also merge this keep it in the center. This can be in bold. Then you can also select the whole table, change the color, increase the font size, 12 font usually for a journal, Times New Roman. Enter. Is that okay?
Yes, sir.
This is enough for your paper. You don't need to spell out anything. That's it. Otherwise, you also can write Pearson correlation. Pearson correlation. This R can be put it in
bracket.
Efficient. This is fine. Okay. So this is shaded. You don't need to have shading. Sometimes they may not have what you call all the lines, dotted lines. Only the top row will have, bottom row will have. In a what you call APA format.
Only the
like
border
bottom, yeah. And the bottom, and then we'll have this line. Only this line. So go to view, then you will come to know remove the grid lines. This is your table. The table, you can copy paste them in your. This is what your table looks like. Is that okay?
Okay, sir.
Okay. So this can be done by grid lines, can be removed from your view and grid lines using Excel. So I would recommend Excel, also fantastic tool for editing your results. In a PhD thesis or any kind of research, we do get a lot of data. Summarizing, organizing the data using Excel is very, very easy. So any researcher, any academician, good in SPSS or good in Excel, so they can do a quality research, quality publications. And then they also feel easy working with. Okay, yeah. Shall we go to the next exercise? And after 10-15 minutes, I may give you a break. Okay, please go to the file, Spearman rank correlation.
1.5.
1.6, sir, 1.6. 1.6.
1.6.1.
Spearman correlation, income versus happiness. So we know that assumption. We know that for purpose of Spearman, one variable is a numeric, another variable is an ordinal.
So 1.6 is Spearman rank correlation, eh?
Spearman correlation, income versus happiness.
Income, okay.
So this is a hypothetical data. This is not a real data. Purposely I created the data. So satisfaction were coded with 4. Very happy to very unhappy. 1 means very unhappy. 4 means very happy. Okay. So in a common population, 2 questions were asked. Please rate your monthly income and the general your happiness, overall your life happiness. You are given 4 options to choose. This is for example. So happiness, for asking only 1 question, we cannot assess. So this is simply hypothetical data. 2 questions asked, whether income is related to happiness. So income is a numeric. Happiness is an ordinal scale. 1 to 4 ranked scale, ordinal scale. Rating. Agree?
Yes, sir.
So please go to analyze, correlate, bivariate, select this and put it here. Okay. Income versus happiness. And then what you need to do? Remove the Pearson, put Spearman. You also can check for why it is not showing sum in ordinal scale. So sum in ordinal, the system is not allowing you to calculate the mean.
Sir, steps again, please.
Okay, sir. Have you all opened the file, sir?
Yes, sir.
Go to analyze, then correlate bivariate, same sir, same step. Analyze, correlate, bivariate. Click on it. In this window, simply you transfer your both variable from left side to the right side. In the correlation coefficient, you uncheck PSN, check only Spearman. By the way, the data also eligible to go for Kendalls. Maybe you can also check along with Kendalls, nothing wrong in that. The purpose of Kendalls and Spearman are used interchangeably. Click OK. Click OK, you will get simple table. The first 2 row for Kendalls, the last 2 row for Spearman. See how much difference, slightly differences is that, Kendalls and Spearman. So Spearman, correlation income versus happiness. How much it is, the what do you call the relationship?
85.
0.851, meaning income increases, the happiness also increased, but may not be right, So please take note, this is the hypothetical data. This is not a real data, just created. This is not a real data. So income increases, the happiness of the people also is increasing. May not be right, but this hypothetical data show that there is a positive relationship. Income increases, happiness, the level of happiness also increased. And the results are statistically significant. P less than 0.01. R equal to Spearman rho. Please remember Spearman rho, not R. The syntax for writing Spearman is rho, RHO, should be italicized. So methodology we need to write. Income actually is a numeric. Happiness was an ordinal scale. And then we have used Spearman rank correlation for to study the relationship between income versus happiness using SPSS version 25. The results show that income and happiness are statistically significant. The Spearman rho equal to 0.851, n equal to 200, p value less than 0.001. Agree?
Yeah.
Yes, sir.
Okay.
So, sir, we can explain any one, either Kendall's or Spearman's rho.
Yes, sir. Anyone can be, sir. Anyone can be.
Okay.
Anyone can be. So, for example, your data both are ordinal. Very well, you have to go for Kendall's. But these two are interchangeably are used. No one will question you why you use Kendall, why you have used Spearman. Okay. Meaning, Spearman is proposed by one researcher, Kendall is proposed by another researcher. That's it. So both can be interchangeably used for this particular kind of data. Okay. Please go to Kendall. Please go to Kendall 1.7. 1.7. Sorry, 1.8 easy. 1.8. Please go to 1.8. Income and tax. Kendall. Participant, please open Kendalls. Yes. So in this particular study, income also rated in ranking. You have given option, some what you call your monthly income less than 10,000, consider low income. 10,000 to 50,000 is a medium income. Anything more than 50, consider high income. So you have asked the population, please rate your income level. Are you low income? Are you medium income? Or above high income? And then what is your burden? Taxation in India is very high. You have asked two questions, whether strongly agree or disagree, etc. Neutral. So what is your income and what is the tax burden? For example, someone is having income less than 10,000. Do they feel any tax burden? Do you think they will file the tax?
No.
No. So they may not I don't feel any tax burden.
Yes.
If anyone is getting more than 1 lakh, they have to go for a filing and they may pay around maybe 10% or 15%. Anyone is getting more than 10 lakhs, sorry, 1 lakh per month or close to 1 lakh. So they may feel more tax burden. So how people they feel regarding income and taxation, to opinion. Some country taxation will be less, some country tax pay also good, tax also good, tax also very high, even up to go for 30%, 35% also. So in Malaysia, for example, anything 100,000 ringgit, the taxation is what you call 21%, 24%. So 1/4 money of your income will go for taxation. There is a slab also. So this kind of study we can run, both are ordinal, we can run Kendalls. So I have coded with like this.
So it means, sir, if we have emotional
Intelligence, emotional, whatever ranking, ordinal
yes,
scale, strongly
we
agree
can
to
use.
strongly disagree, any kind of Likert scale data. If you want to see the relationship, you can go for Kendalls.
Okay, okay, sir.
So income level increases, the tax burden of the people. Is there any such relationship? Lower the income, no burden. Higher the income, is there any such the tax burden? What people do they think? Are they related? Income versus taxation, are they related? For example, someone having very low income, if they feel tax burden, meaning the taxation in the country is very high. Yes or no? So let us see this hypothetical data. Around 24 candidates, the data were collected and the data were coded with in the variable view. Look at here. So 1 means low income, 2 means medium income, 3 means high income. The response, taxation is very high. There are 4 Likert scale. 1 means strongly disagree, 4 means strongly agree, 3 means agree, 2 means disagree. So 4 Likert scale. The data were entered in 1 and 4, 1 and 3 for income, 1 to 4 for taxation, the Likert scale. Shall we run?
Okay, sir.
So this kind of data, participant, please tell me, how do you come to know how many are very high income, how many are less income, how many are strongly agree, how many are, how do you analyze it? What way you analyze it? I do also need for a graph, and then I do need a what you call the summary table. What way you analyze it? Anyone? I have also covered in the first day of the session. Could you please recall and tell me? Could you please recall and tell me what way we can analyze it? Please go to analyze, descriptives. We are interested in, the study was conducted for 24 people. Among them, how many are comes under low income group? How many are
Frequency.
under frequency analysis? Fantastic.
Yes.
Descriptive statistics, frequencies. So transfer your both variable from left side to the right side. Then we can also go for a chart. We can go for a bar chart or a pie chart. Any one can be used for this kind of categorical data. Shall we go for a bar chart?
Okay.
Continue and then click OK, so that you will get a summary data. So this also very, very important, keeping in your results. The study was conducted, but you need to spell out how many are low income, how much percentage of the people are low income. The results show that there are 24 candidates, of which 37.5% of the respondents, they belong to low income group. 25% of the people, they belong to medium group. 37.5% of the participants are high income. Agree? Similarly, for the Likert scale, the response, 33.3% of the people, they said strongly disagree. And agree, for example, around 37% of them, they said agree and strongly agree. So 16.7 plus 20.8, add together. So 37.5% of the candidate agree and strongly agree the taxation is very high. So only 62% of the people, they felt disagree on this taxation is very high. Based on the cumulative percentage, actually the data you can different way you can highlight and present. Yes or no? A study was conducted, income versus the taxation is very high. The results show that 62.5% of the people, they disagree regarding the taxation is too high. The 37.5% of the candidate, they felt taxation is very high. Look at here, income level 37.5. So here, anyone having high income 37.5. People are like, low income, medium income, the 62.5, they do not feel the tax burden. Yes or no? Is that interesting, right? So 37.5% of the high income people, they have rated, I feel taxation is very high in the country. So that is the relationship. So this is a bar chart. You can also improvise the bar chart. Double click using your left mouse, remove the grid line. You also can remove the title of the graph, not compulsory to keep it inside. Right? Suppose if you want to change different color for low income, medium income, high income, you select using your mouse, click on any one of the bar, you click one more time, so that low income only selected this time. Change the color here, and then select the other one, change some other color. Go to the other one, change the color. Is that fine? So now, suppose if you feel the table and the graph are redundant, you are interested only keeping only the table, sorry, graph. Just you can also give the percentage inside. Double click the graph, click elements, show data labels. Show data labels, apply, close it. Elements, show data labels, that's it. So along with the graph, you also get the frequency and percentage. Is that easy to go for it? Is that interesting?
Yes, sir.
Similarly, you can also edit the graph, remove the grid lines, delete the title, elements, show data labels. You also can try changing the color. So agree means you can go for a green color. This can be other side, they don't feel, you give it them another color. So agree and strongly agree. Something is missing, show data label, all the graph need to be there. Yeah, that's it. Anyone do have a difficulty for conducting frequency analysis and having the graph?
Sir, can we have these two in one graph?
Say again, ma'am.
Can we have these two data sets or these two variables in one graph?
Possible, but okay. Please go to analyze, ma'am. Please go to open the data file, go to analyze, descriptive statistics. Can you please go to explore? Sorry, go to analyze, descriptive statistics, explore. Do you have this window? So taxation, you put it in the dependent, income, you put it in the factor. Taxation,
income
you put it in the dependent.
Yes, sir.
And income in the factor.
Yes, sir.
Wherein you could see the plot.
Yeah.
Sorry, ma'am. Sorry. Not this approach. Sorry. I made a mistake.
The normality test is...
No. This is not the approach. we have to go for cross tabulation. Sorry, go to analyze, descriptive
sir.
statistics, cross tabulation, not explore. Sorry,
Cross
cross
tabs.
tabulation, cross tab.
Okay.
In that, you can transfer income in the row, respond in the column. Okay.
Then sir, any options?
Options: display clustered bar chart.
Display
I think, yeah, that's it. That's it. Click OK. You will have a simple bar chart. Yes or no? So these are low income. They are happiness. Sorry, their tax burden frequency. These are low income. These are medium income. These are high income. The agreement, all high income. So in the high income, no one has strongly disagree. All of them, they felt disagree, agree, and strongly agree. In the medium income, no one is agree and strongly agree.
There are
nobody chosen that particular option. In the low income, only one or two candidate, they felt low income. The rest of them disagree and strongly agree. Yes or no?
Yeah. Thank you.
So this way you can simply also you can put together and go. Agree?
Yes, sir. Go
Okay.
ahead, sir.
Shall we run the candles for this? Shall we run the candle for this data?
Yes, sir. These are ordinal.
Go to both are ordinal. Low income, medium income, high income. Strongly disagree to strongly agree. Go to analyze. Correlate. Bivariate. Analyze, correlate, bivariate. Select both the variable. You remove the PSN. You check only the candle. Is there any relationship? Income versus the taxation in the country is very high. How much? How strong the two variables are related? Is there any relationship? Click OK. So tell me, what is your conclusion, interpretation on this? What is the conclusion and interpretation on this?
There is moderate positive relation between two variables.
Fantastic. Moderate, not a very strong relationship, moderate. Around 57.6% of the paired responses, income increases, the tax burden of the people also increases. Around 57.6% of the respondents. The paired data, one increases, other increases. Income increases, the tax burden increases. But the results also statistically significant. It's a moderate. Yes, tell me, ma'am.
Sir, these are non-parametric correlations.
This is non-parametric correlation, ma'am.
So, if we have scaled variables, but those are not non-parametric or those are not normal, then we have these candles.
Ma'am, your voice is not clear, ma'am. Could you please little louder, ma'am?
Sir, if we have the scaled variables, but those are not, can we have
you can go. You need to go for sphere, ma'am. You cannot go, ma'am. You cannot go. Candles means ordinal. Not non-parametric means you please go to Spearman, ma'am. Spearman. Not normal data. Go to Spearman. Both are continuous.
Sir.
Yep.
This result came, I think, just due to the data, whatever we have here now. Otherwise, if we see the person who has low income, certainly will disagree for the income tax.
Yes.
So if by this way, if we think that it is directly, it should be strongly correlation.
Yes, sir. So income
but here,
and
yeah, it's showing that it's moderate correlation.
Yes, sir. Moderate correlation. Yeah, correct. Even in the high income also, high income also, some people they felt disagree, sir. Not all the 100% of the
That's why
people.
this is the result.
This is
Okay.
due to this high income
Yeah.
also, some people they felt, okay, I'm getting money, but I'm paying back to the country. I don't feel it's a burden. Some people they take it like way. So some people
Yes.
also they felt disagree. Okay, taxation is normal. I worked in other countries. They are very, they are charging more. But compared to
Yes,
other
yes.
country, India is okay. I don't feel tax is a burden. Compared to other country, our country, the taxation is very less. So due to these reasons, moderate correlation, sir. Not 100%
So for this
correlation.
moderate correlation, we can explain in the paper that this is the reason why this shows.
This could be. Not the study was conducted for 24 people, sir.
Yes.
Around 50% of the people saying that, yeah, taxation is very around 57%.
Okay. Okay.
37% of the people, they are come under low income, medium income. They don't feel the tax burden. I hope agree.
Yes, sir. Yes.
Is that justifiable, sir? Yep.
Sir?
Yep. Please tell me, ma'am.
There are so many functions in the menu. So
Your
how
voice
to
is
make
your voice is not audible, ma'am.
Sir, there are so many functions in the ribbon menu. So how to be clear that which particular function is to be utilized at the time of requirement?
Or this menu bar, ma'am.
Yes, sir.
Frankly speaking, we cannot remove any menu bar. You cannot remove
Yes,
anything.
sir.
All of them need to be kept. This is inbuilt function, ma'am. We need to remember where a particular test is located. This is inbuilt. You cannot remove like Excel. Excel, the ribbon can be adjusted. So cannot. So as of my knowledge, I don't think so. We can remove any one of the panel. Okay. Shall we move on?
Okay.
I think I will give you 5 minutes
Sir.
break. I will give you 5 minutes
Sir.
break. Yep.
Sir,
Excuse me.
Shall we
Sir,
discuss
sir.
after 5 minutes break, sir? Yeah, please.
Yes.
Okay. So 5 minutes break.
Okay,
Then you
sir.
come back. We'll go for partial correlation and linear regression.
Okay, sir.
Okay. 5 minutes break. Hello, anyone, any doubts so far? Somebody asked me before break. Do you have any questions so far? Any clarification need to be discussed before we move on to the next topic? Any doubts so far? If not, we move on to the next exercise.
Sir, can you hear me?
Yeah, I can hear you.
Sir, can you hear me?
Yeah, I can hear you.
Sir, in this graph,
Ah.
the orange color, that is strongly agree group in between the low income and middle income.
Okay.
That will be of which group? It's maybe a silly question.
Say again, I didn't get your point, ma'am. Your voice is little audio, fan sound. I can't hear you.
Sir, this strongly agree group in between low income and medium income.
Please, I didn't understand your question fully.
Hello?
Yes, yes.
Actually, it is medium income, ma'am.
This is the median one, is a medium income.
It will be coming under medium.
This is a medium income, ma'am. This is high income group. This is low income.
Okay, okay, sir.
Maybe you can put the points so that you come to know. So there is only one candidate high income. He felt taxation is, I don't feel high income strongly. Sorry, this is a disagree. 4 agree and 4 strongly agree. Whereas in this medium income, 3 of them among the, what do you call, 3 of them, they felt strongly disagree and disagree. Whereas in the low income, only one candidate also felt agree, strongly agree. I don't know. Maybe his wife or someone else, maybe, having, or based on the family, someone's, he might have given influenced. So this is inference. So this is actually, it's not a real data, it's a hypothetical data. We wanted to show you how ordinal data can be conducted using Kendall's correlation. Okay, shall we move on for a partial correlation? Participant, shall we go for a partial correlation?
Okay, sir.
Yeah. So when we can use a partial correlation? So partial correlation analysis is a measure of the strength and direction of the linear relationship between two continuous variables while controlling the effect of one or more other continuous variable. We can call them as a confounding variable or covariate or control variable. So we are interested in study X and Y variable. In addition to that, another variable also may influence the relationship between the two variables. So partial correlation between two variables is taken into account by nullifying the effect of the third variable or fourth variable upon the variables being considered. It's called partial correlation. So to nullify the other variables to study the relationship. I'll give an example. So assumption, whatever we have seen in the Pearson correlation are same. You have to have one dependent variable. The dependent variable should be continuous or interval ratio. Same as assumption for Pearson correlation. Conducting the partial correlation, you have to have one or more control variables, covariate. It can be continuous. Assumption 3, there should be a linear relationship between all the three variables, your X and Y and Z variable. there should not be no significant outlier. The data should be follow approximately normally distributed. So this is basic assumption for partial correlation. Say here, one example. A researcher want to know whether there is a statistically significant relationship between VO2 max. Remember, VO2 max is nothing but it's a kind of marker. How much a person can have breathe in and how much oxygen he can keep it inside. This can be measured in ml per minute per kg. This is the one unit. The capacity of the candidate, aerobic fitness. How much maximum? So whether this can be related with the person weight. Someone is heavier, whether what is their capacity of VO2 max. So person weight is an independent variable. VO2 max is a dependent variable. So these two can be influenced by a person age. For example, someone 20 years old, he will be 100 kg. Someone will be 70 years old, maybe 45 kg. So the person weight and VO2 max, is there any relationship? So these two relationship can be influenced by another variable, a person age. So when nullify the person age, what is the relationship between the person weight and VO2 max? Agree? Agree? So otherwise, I will give you another example. Another example, let me see whether I have any other example here, easy for you to understand. Okay. Another example, maybe we can say advertisement versus sales. Advertisement versus sales, and then the number of years the particular brand is available. The particular brand or the company, what you call the number of years they are in the market. So advertisement and sales, and another.
So basically, there will be three variables here, sir.
Yeah, three or more than that, sir. Your main variable, dependent variable, is a sales. Advertisement is an independent. Sales is a dependent. In addition to that, company brand, company reputation, number of years the company they are running in the market also may influence us. How many years they are in the market. So that year also influence the relationship sales and advertisement. I'm giving you one simple example.
Additional variables are affecting the same.
Agree, sir?
Additional
independent variable, one dependent variable, one control variable.
Okay.
Second, sir?
This will be the number of years will be the control variable.
Control variable or covariate. We can call them as a covariate.
So just like in previous example, the number of years of the age.
Age is a confounding variable or control variable or covariates.
Okay, sir.
Well understood. So nullifying the effect, please tell me, are they related? Does advertisement and sales, are they related? Nullifying the effect of number of years of the company are in the market. Is there any sales and advertisement? Are they related? So you need to key in the data in Excel, sorry, in SPSS.
So which data, sir?
I didn't open, sir. Just I'm explaining. Then I will open it.
Okay.
So in SPSS, you need to key in all your data in 3 columns: X, Y, Z. So once you are key in, you need to go to analyze, correlate, bivariate, partial correlation. Correlate, below the bivariate, there is a partial correlation. So you will get this window. In this, your independent dependent variable need to be in the variables. Your controlling variable should be in the controlling. Your confounding variable or covariate should be in the controlling. So in this case, weight and VO2 max should go into this. Age should go into this. All right. So next one, click option. In that option, you please select, we have to tick these 2. Then continue, then click OK. The system will give you simple table like this. Simple table like this. The system will give you, and then we can interpret the results like this. I have given you how to write the results. I'll come back to you. Shall we run the analysis? Then we can discuss the result. Okay. Shall we run the analysis? Okay. Please go to the file 1.9 partial correlation. 1.9 partial correlation. Let me see. I do have any other partial example. think I have only one correlation. Yeah. Okay. Right. Please open the file. 1.9 partial correlation. I have one more also. I'll come back to you. Yeah. 1.10 also there. Okay. 1.9 partial correlation. Have you all opened it?
Yes.
Study was conducted for 100 people. There are 3 variables are recorded: weight of the candidate and how much the aerobic capacity, VO to max. Please remember some number, some numeric. Weight and VO to max, the aerobic, how much, maybe their breathing capacity, etc. So we are interested in weight. Weight increases, the VO to max increasing or decreasing. Whether this weight and VO to max, are they influenced by age? Age influences these two, the relationship. We are going to run partial correlation. So assume that all the variables are having normality assumption. The data is eligible to go for PSN, partial correlation, parametric. Shall we go? Go to analyze, correlate, partial correlation. Partial correlation. Click on it. So weight, VO to max. You select, you transfer into the variables. Age controlling form. Age controlling form. Have you all done it?
Yes.
Yes, sir.
Then click on option. Very, very
Yes,
simple
sir.
actually. Very, very simple. Conducting correlation and regression. Very simple using SPSS. Click on option. You select both. The statistics, means and standard deviation, 0 order correlation.
0.
Continue. So think about it in your field of study. Where, when we can use a partial
Sir,
correlation.
one thing
Yeah.
here I want to ask, why we select two-tailed, why not one-tail? Will you elaborate for one-tail and two-tail, please?
Okay. For example, sir, you have some idea. If you have some idea, meaning before conducting any study, we may not get any clue. The relationship can be or cannot be. Say, sir, no, until you get valid evidence, we do not know. So usually, I do not know whether what outcome I am going to get. Maybe there is a relationship or there may not be. In those conditions, we go for two-tail.
Yes.
Suppose you are very sure about it. You have some idea. Yes, there is a relationship, meaning you can go for one tail, positive or negative. Suppose you have a positive, you go for one tail, or
Yes.
otherwise you are very, very strong. You may have a negative relationship, you go for one tail. But most of the statistical software, it comes with two tailed, sir.
Okay.
Two tail, you don't need to change it to anything.
Okay. Okay.
If you are not very sure about your nature of your data, we proceed with two tailed. If you have some idea, or you have some
So
kind of
safe
some
side is
notion,
to process with the two-tail. Safe side.
yeah, yes, two-tailed test. We do not know the relationship, so not equal. Not there is no relationship. When you state the null hypothesis, then you go for two-tail. Okay, click OK. So we'll get sample table. So this is the descriptive statistics. The average weight of the 100 people 77 kg, plus or minus 19 kg. The average age is 40 years, plus or minus 13 years. The VO to max average 43.10, plus or minus standard deviation of 6.7. So this is for you to elaborate your descriptive in your result section. A study was conducted, 100 people where the data were collected like weight, VO to max and age. Descriptive statistics was analyzed using SPSS. The mean and standard deviation was found to be like this. The mean weight, mean VO to max, the mean age like this. Then we need to go for the correlation. So descriptive statistics show that there is no any missing data. The recorded sample size n equal to 100. The number of participants were involved in the study 100. So we can also see that the mean value of the dependent variable VO to max 43.10. The unit Standard deviation 6.67, sorry, 76, typo error. The mean weight of the participant 77.32 plus or minus 19.57. The mean age of the participant 40.59 years plus or minus 13.08. So this way you can elaborate your descriptive statistics. Then you move on to the next table. The result of the partial correlation highlighted in this second row. The first row without the age. The second row with age. So weight and VO2 max, how much is related? Please tell me this one. What kind of relationship?
Strongly negative correlation.
Strongly negative correlation, meaning, so weight increases, the capacity, the VO2 max aerobic capacity decreases. So weight increases, the VO2 max decreases, but controlling age, how much, whether age influences them. So there was a high negative partial correlation observed between the dependent variable VO2 max and the independent variable weight while controlling for age, which was statistically significant. R equal to 97, the number of candidate, n minus 3, reason 3 variable, R equal to this, n equal to 100, p value 0.05. This is the p value. This is a p value. So however, when we refer to the previous one, Pearson product correlation, this is actually a real correlation without age. So the first one, it conducts weight versus VO2 max. Weight versus VO2 max. This one. Or weight versus VO2 max, this one. You need to refer this one. SPSS will conduct all the three variables, the correlation. But we need to compare the intersection. Weight versus VO2 max, this one. So without age, the correlation was found to be negative 0.860. So nullifying the age, the correlation slightly, the negative correlation slightly influenced. Meaning, how do you write actually? When we refer to the Pearson product moment correlation, and otherwise zero order correlation between VO2 max and weight without controlling age, in the first row, we can see that there was also a statistically significant high negative correlation between VO2 max and weight. You write this value, n equal to 100, p equal to 0. So the result suggests that age had a very little influence, 0.864 and 0.860. So there is a slight influence controlling the age. Say or no? Say or no? Slightly increasing, the age slightly increasing. 1 year age increases, slightly the aerobic also negatively the related. 1 year age increases, the relationship again slightly negative. Is that okay? Is that okay? Is that okay? So in a nutshell, in a result section, you can write like this. In a research paper, when you conduct a partial correlation, you just copy and paste this and put up the value, that's it. And in change your independent dependent variable. A partial correlation was conducted to study the relationship between individuals VO2 max and weight, controlling the age. There was a high negative partial correlation where a dependent variable and independent variable, all the variable, the summary statistic, descriptive statistics was given, statistically significant, R equal to 97. And this is the correlation. Controlling age, this is the correlation, n equal to 100. However, the zero order correlation showed that there was a statistically significant high negative correlation, VO2 max and weight, n equal to this, R equal to this, p less than 0.00, indicating that age had a very little influence in controlling for the relationship between your dependent variable VO2 max and the independent variable weight. So this is the sentence. This is the way you need to write. So 2 or 3 sentences in a nutshell. Very briefly, we need to write the correlation. Agreed? Scientifically. Is that fine, sir? So we need to capture the numeric also into your the statistical inference also into your writing. We should not write only the. So the results show that there is a significant relationship. We should not. We have to include the numeric also inside that sentence, so that while reading the manuscript, the reader or viewer or what you call someone reading a paper will have a good impression and also will have a good idea about your study, and your paper also will get citation. So reading
Sir,
a paper, you should have interest. Reading a paper should have interest, you know. Maybe you also can publish a lot of paper. 5 years nobody has cited your paper, meaning so your paper somehow is not what do you call not reached to the audience. Interestingly, we have to write. Yeah, please
so
tell me.
here, sir,
Yep.
here in inference, no need to write the descriptive statistics.
That's what I have written, sir, here. Descriptive
Oh,
statistics are written here.
Okay, you have written, yes, sir.
I have written, sir.
We can mention it. We can mention here also.
Yeah, you need to
Okay.
mention. We need to mention. Actually, 2-3 sentences, sir. The whole
Yes,
study is a huge data, but we have summarized it in 2 sentences.
Okay,
This
sir.
is what in a page, what you call the journal they prefer. This is what. So when you write like this in inference in your thesis or your
Sir,
paper,
one more question,
Yeah.
just the basic question. So we can find the correlation from the second. You can say the correlation from the second table.
okay.
So we can already conclude our result. So
Yeah,
why we are
yes.
mentioning this descriptive statistics? Is there any significance of?
We need to spell out, no, sir. We need to have the highlighting the results also. This is what normally the 2 sentences only write to a paper. This is the descriptive statistics about your what you call overall overview, nature of your participant. How old are they? How weight are they? What is the average? What is the deviation? But the second sentence is about the statistical
main
inference
purpose.
about the
Yeah, yeah.
relationship. Yeah.
Sir, I have a question. In case of ordinal scale, how we can run the partial correlation?
You can also keep your what you call controlling variable. Partial ordinal also can be included.
Okay, the same path we can run the partial correlation with the ordinal scale.
Ordinal controlling variable. Yeah, control variable.
Okay.
Yeah.
Okay.
So,
Thank
sir,
you so
it
much.
means whether it is ordinal or any other data, we have to keep in mind that if there is more than 3 variables.
Yeah, should have
Then,
different. Definitely, your study should have 3 variable, but your
three
independent
variables.
dependent should be numeric, sir. Independent dependent numeric.
Okay.
Independent dependent numeric, but your control
Yes.
variable can be ordinal.
So, sir, it is also possible that controlling variables may be more than 1.
You can have, sir, more than 1 also possible. For example, you have age, you have some other variable possible.
Maybe the male female.
Male female is a kind of qualitative, sir. You should
So
have.
we
You should
cannot
have.
run.
Yeah, maybe you can have the blood pressure,
Because
systolic
the
blood
weight-
pressure, systolic
the
blood
weight,
pressure,
age-
number of age or number of hours they do exercise.
Okay.
Number of hours daily they do exercise.
Exercise. Okay.
Okay.
Sir, in
Age
case
can-
of mediating role or mediating model, we can
Yeah.
use the
Partial correlation.
correlation.
Also
Okay.
can, ma'am.
So for the
So actually, any moderating, any mediating variable, if you are going to go for
Okay.
relationship, actually the controlling variable covariate is nothing but moderating or mediating variable.
okay.
Covariate is nothing
Right.
but moderating or mediating variable.
Okay. All right.
Okay. Yeah.
Thank you.
So I given you the steps, the Kendall, how to go, when to go. This I think the manual will be useful and writing the inference. So the last test is for today's session is a linear regression. So when to use and how to use the assumption. The assumption, whatever we have in correlation, say. Correlation is meant for to study the relationship. Regression is meant for prediction. We can predict, estimate, we can anticipate. So regression, simple linear regression, meaning you have one x variable, you have one y variable. The person height and the long jump performance. Advertisement versus sales. So sales is a dependent variable. Advertisement expenditure is an independent variable. So can we predict the sales from advertisement? We can run for the regression analysis. Have you got it, sir? Have you got it, all the participants?
Yes.
So when to use the correlation? Correlation is meant for to study the relationship. whereas regression is meant for prediction. Whenever you have food intake, amount of food you consume and your body weight gain, amount of drug you have taken and the blood pressure, age versus systolic blood pressure, age versus cholesterol, age versus your blood glucose level, income versus some other what you call expenditure can be related. So temperature increases the metabolic rate of animal. Is there any relationship? Can we predict at what temperature how the metabolic rate will be? At 30 degrees Celsius, how metabolic rate will be? Another example, if I spend this much money for advertisement for my company, how much the sales I can anticipate, I can predict. Is that okay? So this kind of situation, this kind of scenario, you can go for a run linear regression. So assumption, same, your dependent variable continuous ratio interval. There should be a linear relationship and there is no outlier, extreme value. We can run Pearson correlation. So x-axis, we have to keep our independent variable. Y-axis, we have to keep our dependent variable. Then we also can run the linear regression. We'll be able to predict the line of best fit. The line of best fit. I will demonstrate the importance of this. So linear regression can be conducted.
What is the third assumption of this linear regression, sir? You have
third assumption, sir.
Yes.
That should be no significant outlier, sir. No
Oh,
extreme
no
outlier. So we're having this
we have
extreme
to check
outlier.
first the outliers. Eh?
Yes, outlier.
Okay.
Need to remove by conducting scatter plot.
Yeah.
You can remove that.
Okay. If there is no significant outliers, it means we can run this linear regression.
Yes, sir. Yes, sir. You're right. So
Sir,
then scatter. Yep.
Can you show us how to remove that using scatter plots?
Say again, ma'am.
Can you show how to remove the outliers using scatter plots?
You cannot,
here in
by
SPSS?
conducting scatter plot, we will come to know whether yes or no. But manually, you have to remove. The value manually you need to remove. I'll come back to you, ma'am.
Okay,
I'll
sir.
come back to you. Wait.
I think, sir, that will be the cleaning part.
The cleaning part, data cleaning.
Yes.
Data cleaning. So, in maybe you can have like this data, length and tail length, age versus systolic blood pressure. So age increases, the systolic blood pressure is increasing or not. Is there any relationship? For example, your age is 60 years old now. How much approximately my blood pressure will be? I can anticipate based on this. So, do you think only age influences? There are several factors, but we do not know. Age is one among the factor, but there may be several factors. Maybe weight could be one. Your amount of food consumption, your dietary habits, vegetarian, non-vegetarian, amount of oil intake, daily exercise. Do you practice any yoga, whatever it is? So there are several factors, or hereditary factors also may influence the pressure. So based on age, how much age influences, we can predict. So linear regression, we used to get a equation y equal to a plus bx. A is nothing but intercept. B is nothing but a slope. X is your independent variable. Suppose I'm interested in 4 lakhs rupees for advertisement, how much income I may get. I can anticipate, I can predict using this equation. So here y is the dependent variable, y-axis dependent variable, x-axis independent variable. This A is a intercept. Intercept is nothing but when you do the trend line, the linear line, where exactly the line connects the y-axis. When your x variable is a 0. When x is 0, how much your base value or dependent variable. That is what intercept. Slope means delta y divided by delta x. Otherwise we call them as a b. The slope. Delta y divided by delta x. Okay. So no need to worry about this graph. In SPSS, system will give you very straightforward A and B. With that, we can easily infer the prediction. So I will demonstrate using Excel. I also demonstrate using SPSS. So linear regression estimate the coefficient of the linear equation involving one independent variable and one dependent variable. Birth weight of the baby and blood pressure of a baby. So what is a normal baby weight participant? the previous class also. So newborn baby weight 2.5. So one researcher, one researcher compiled the birth weight of a baby and the children blood pressure. So birth weight influences the blood pressure of a baby. Can we predict if a newborn is 3 kg, how much blood pressure will be? We can anticipate or we can predict. So blood pressure equal to y equal to a plus bx. Y is blood pressure, a is intercept, b is a slope, and then you can keep the body weight here. X is a body weight. So when you substitute the body weight, someone body weight, you come to know the blood pressure exactly. We can anticipate, or we can we can predict. So another example in advertising, for example, someone conducting a car sales, whether income is related to how much car they look for it. Do you think income influences the purchasing, the price of the car they go for it? Suppose someone is getting 15 lakhs per annum, how much car they may go? Depends. Suppose someone annual income is 4 lakhs, they wish to go for a car, they may go for low end car. So income influences the car price they are going to go for it. So any agent they can predict, please tell me your income, so I'll advise you what kind of car you can go. Based on your income, I can suggest you monthly payment, whatever it is. Based on the income, I can suggest you what kind of car you can go based on the price. Yes or no? A salesperson in a large car brand wants to determine whether there is a relationship between individual income and the price they pay for a car. So based on that, we can predict. Suppose someone income is 7 lakhs, so how much the price they may ready to pay for a car, the salesperson can recommend a particular car. Have you all understood the concept? Have you all understood the concept?
Yes.
So
Yes,
in SPSS, we need to key in
Yes,
the
sir.
data like this: income and price. Income in one column, price in another column. To go for regression, click analyze, regression, and linear. Wait for a while. I'm demonstrating only. Then we can open the file, the same file, we can run the analysis. So you will get this income. Income influences the price. Says or no? So what is dependent? What is independent here? A salesperson conducting
Income, independent.
Income influences the price they pay for it.
Yes.
Price is a dependent.
Income independent.
In salesperson point of view, price actually is a dependent. Income is an
Yes.
independent.
Independent.
Suppose you are interested in age versus systolic blood pressure. Age increases, systolic blood pressure is increased. How much blood pressure will be? So tell me, what is your dependent, what is your independent? Age versus systolic blood pressure.
Age
Age is the
independent.
independent.
Age is
Systolic.
independent. Systolic blood pressure dependent. So please remember, the variable you are going to predict. The variable you are going to predict is a dependent. The variable you are going to predict should be in the dependent. The variable influencing your variable. A variable influencing your dependent variable is an independent variable. Agree? Agree?
Yes.
So here,
Yes,
price, income influences the price they go for purchasing a car. Income of a candidate influences the price of the car they are ready to pay or purchasing the car. Agreed? So transfer your income in the independent, price in the dependent, and then click statistics. We need to go for estimate. Then confidence interval also can. And then continue. You will get sample table like a model summary. You'll get the first column is a Pearson correlation. Second column is R square value. R square value is nothing but when you square this R value, you will get R square value. Okay, when you square this R correlation coefficient value, you will get the R square value. What does it R square value explain? What does it R square value explain? So 91% of the people they pay for the car price can be explained by, can be influenced by income. So 91%, the people they go for purchasing a car, the price they pay for can be influenced by their income. So only 9% of the variance you see in purchasing a car maybe some other factor. Maybe their family background, their wealth, or both husband and wife working, or maybe some other wealth, maybe several factors. So which is very good. R square value anything 0.5 and above is well and good. 91%, which is very good, right? 91% can be explained by the price. The price can be explained by the independent variable income and influences the price by 91%. Any doubt so far? Any doubt so far?
No, sir.
Okay.
And
So
what
then
is
the
adjusted R, sir?
adjusted R square is not needed for a simple linear regression, sir. Adjusted R square is not needed. For example, in multiple regression, adjusted R square is needed. Adjusted R square is explained nullifying the other effect, nullifying the other variables. Then we can. So in what you call linear, simple linear regression, you can use R square. When you run the multiple regression, you can use adjusted R square.
Okay.
Need to be adjusted. Okay. So this then SPSS also will give you. You are going to go for regression, well and good, but whether your independent variable significantly predict the dependent variable, your income significantly predict the price of the car they are going to go for it, we need to refer this table, ANOVA table. This value we have to capture. So ANOVA need to significant. This particular table need to be significant. So this will tell us, in this example, the income influences significantly the price they are going to go purchasing the car. So the model is significant. With this model, we can anticipate. With this model, we can predict. With this model, we can predict the price they are ready to go for purchasing a car by income. Agreed? Agreed, sir? So then,
Sir, can we say that here in this model, it shows the significance of this model by
fantastic,
0.00?
sir. Yes, the model is significant. P less than 0.05. This should be significant.
Okay. Okay,
Suppose your ANOVA table says that your P is greater, the significant value greater than 0.05. In that scenario, the model is not significant. We cannot go for it. Meaning,
So
there is
what
no
would be the range of the significance level, sir?
less than 0.05 means we can go for it, sir. If
Okay.
your significant
Yes.
value less than 0.05, the model is significant. If anything more than that, anything, if your P value anything more than 0.05, you conclude that the model is not significant. Your independent variable significantly not predicting the dependent variable. Otherwise, your income is not predicting the price. Yeah, when your P value greater than 0.05. I hope you would have understood. Okay.
Yes.
So then this is very important. Coefficient table. So the first one is a constant. Second one actually is the slope. This is A and this is B. So 1 unit of income increases this much unit of money they invest in car. This much unit, one unit of income increases, this much unit they're ready to pay for purchasing a car. Okay. Otherwise, every 100 rupees increases. Imagine that 6 rupees they are ready to pay for car, approximately. And this is significant. Both are significant. And then we can, this is the equation y equal to a plus bx. Capture this value plus this value and put someone income. For example, someone income is 2 lakhs or 3 lakhs or 10 lakhs. With that, we can say that how much price car they can go. All right, participant? All right, participant?
So will you this one coefficient, please?
Second, sir?
So will you repeat this one coefficient?
Yeah, 1 minute, sir. We'll run the analysis, then I will explain you.
Okay, okay, sir. Okay.
Run the analysis, then I will explain you. Yeah, please. Open the file. Yeah, 1.11. Simple example, 1.11. So this is their income, monthly income, and the price they spend for purchasing a car. So someone monthly income at 10,000, he gone for a small car. Someone the monthly income is 1,50,000, they have purchased around this much worth car. Okay, so this is the based on the data. A company selling the car based on the previous record, they found that Someone having 20,000 per month income, they spend this much money for car. This is again it's a hypothetical data. Someone monthly income is 25,000, they have gone for 25 lakh something worth car. So is there any such income influences the price they go for purchasing a car? Right? So assume that the values are normally distributed. We can run by scatter plot as well as regression. Go to chart builder. Go to chart builder. Click scatter. Click scatter. Can you please see the second graph? Simple scatter with fit line. Just drag and leave it here. So please tell me what variable you have to keep it in the y-axis. Many times I repeated.
Price.
What variable?
Price.
Dependent variable on the y-axis.
The price should go into the y-axis. Income should go into the x-axis. Agree?
Then okay.
Agree? Then click OK. You don't need to do changes. You don't need to do any changes. So is it steady line? Is it significant? Income
Yes.
increases, the price they go for a purchasing car, is it increasing? So 91% of the price variance can be explained by income. So people so far they have purchased a car. Higher the income, higher the money they paid for the money for purchasing a car. Significant. So with this, we can predict. Someone audio is not muted. Please mute your audio. Extra noise is there, please. Someone audio is not muted. Some noise is coming, please. Okay, so disturbing. Yeah, thank you. So this is one way to do, a graphical way to do the regression. Agreed? Then we also can include the regression equation. Something's wrong, sorry. I'll leave it. I will explain you another way. Yeah. Go to analyze. Go to analyze. Regression, linear. Regression, linear. So price should go into the dependent. Income go into the independent. Price into the dependent, income into the independent. Click statistics. Coefficient by default has been chosen. Coefficient by default has been chosen. If you are looking for confidence interval descriptive, you can choose. Nothing wrong in that. Remaining all, you proceed with the model
So
fit.
in a statistics, what should I choose, sir? In a statistics,
estimate confidence interval descriptive, sir. Estimate confidence interval descriptive. Continue, then click OK. Continue, then click OK. You will get the output. Please tell me whether you got the output. So the average and standard deviation, there are 20 candidates, the data were collected. This is a Pearson correlation. Increasing steadily. This is the model summary. R value and R square value. So 91% of the variance you see in the price they paid for the car can be influenced by or can be explained by the monthly income, which is very good, 91%. So ANOVA table says that the model is significant. The model can be used for prediction. And this is what we are interested in. So what do? You copy this table, coefficient table, participant, just copy this. Copy this. Open an Excel file. And copy the coefficient table. Open an Excel file. And paste this. Please remember, this two value only we are going to go. This value only we are going to go. Okay. So this we call them as a intercept, otherwise A. Otherwise A. This is slope RB. What is the equation? Y equal to A plus Bx. A plus Bx. So, shall we go for it? Price equal to A plus B bracket income. Okay. Participant, can you all hear me?
Yes, sir.
Okay, can you hear me? So silent. That's what I asked. Sometimes my internet is very poor. I don't know. I'm speaking alone.
Yes, sir. Yes,
Okay.
sir.
Yes,
Okay,
sir. We
okay,
can hear
fine.
you, sir.
Yeah. Okay.
But
okay, fine,
because
fine.
of the disturbance, we
Yeah.
mute,
Thank
sir.
you. Thank you. Noted. Noted. Yeah. Very good. Yeah. So now someone is income. Let's say around 70,000. Around 70,000. Income is 70,000. So how much this person can go for purchasing a car? How much he can go? Shall we go for it? Equal to, what is the A? A is this value. How much we can write? 96,017.090 plus 6.376 multiply with 70,000. Okay. We come to know this person how much he can spend for purchasing car. The salesperson can predict, he can recommend what kind of car. Please tell me what is the amount? Approximate. This is actually is approximate. Maybe the Indian context, I don't know this particular this work. So based on this hypothetical data, a person can go around 5,42,000. 5,42,000. Is that okay? Is that okay? Based on this income, the candidate can go up to this much based on this hypothetical data. Suppose someone has got 80,000. Can you multiply this? Someone got 80,000 income. How much he can go? So copy this, paste it here. Instead of 70, just to change it 80. So he can go up to 60,000, 6,60,000. Is that okay? Is that okay? 6,60,000.
Yes, sir. Yes, sir.
So this way we can predict and go for
Sir,
it. Yep.
sir, can this projection be true? Because there are many factors which can affect the pricing level of purchase.
Yeah. Yes, sir. So we have actually only two. The salesperson has taken only two. He is interested in income influences. Suppose the salesperson interested in some other, whether they have any other car, whether both husband and wife are they working, do they have any house loan? Is that okay?
Yes, sir. Yes, sir. Yeah.
That also can be influenced. If they have a house loan, how much car they are afford to go? Let's say depends. So that can be conducted by multiple regression.
Multiple regression. Okay.
Multiple regression. This is one by one. One is to one independent, one dependent.
One dependent.
Okay. So with that, shall we conclude today's session? If there is any doubt, we can discuss tomorrow. Yeah, please tell me. Any one question?
No, thank you, sir.
What is the use or interpretation of this standard error and T statistics here?
Say again, ma'am.
What would be the interpretation of standard error and T statistics here.
Actually, the value should be significant. The last column, significant should be,
Okay.
this last column should be less than 0.05. And
Sir,
the T
the coefficient
higher-
of standard error is so much high that that is not a problem.
Which, say again, ma'am. Say again, ma'am. I didn't get you.
The
Coefficient?
standard error is so much higher, na?
No issue, ma'am. No issue, ma'am. No issue. No issue. So, but still, this is significant, ma'am. This is significant. So your model is significantly predicting income influencing the price significantly. You don't need to worry. Anyhow, you will be giving this table, and you will be giving this table also, the p value, the f value, and the p.
So you have taken the numeric data, like income is very well calculated, but if we really talk about the behavioral parameters, how we can go ahead with that?
Behavioral means any example, ma'am?
Like job satisfaction is one. If I wanted to predict on the basis of the the other variable,
Okay.
which maybe organizational commitment or
Okay. For
organizational
example,
service.
job satisfaction, and you can predict the turnaround, something we should call, right? Turnover.
Okay.
Number of people they go for a very frequent resignation.
Okay. Then we
So,
can look in for the ANOVA table.
Yeah, we can. Yes, ma'am. So job satisfaction influences the people resignation, number of resignation. What is the
Okay.
terminology normally use it for, turnover or turnout?
Employee turnover intention.
Employee staying intention. Is it staying intention?
Yeah, this is one of the common
Okay.
which comes.
So again, so how job satisfaction in India influences people staying what do you call?
Sir, it
staying
is
in-
called retention. Employee retention.
Retention.
Okay, so this could be also influenced by the job availability. So
No, but
how
sir, how we can predict? I mean, how we can put it in the the equations?
That we have to go for multiple regression, ma'am.
Okay. All right.
So 1:1 means we need to go for this y equal to a plus bx.
Okay.
Multiple equations. Tomorrow we are going to discuss, ma'am. Don't worry. We have
Fine.
couple of
No
exercise.
issues. Anyway, thank you so much, sir. You helped me. You answered me offline also. I messaged you. Thank you
Okay.
so much for that also.
Okay. Okay. May I know who is this?
Thank you.
This is Manisha. I messaged you and you replied back immediately. That was really appreciable as a,
Oh, okay.
a scholar.
Okay, ma'am. Yeah.
Thank
Okay, ma'am. Thank you. Keep in touch. Yeah.
Thank you.
Right, ma'am. We'll see you tomorrow. Yeah.
Sure. Thank you.
Okay. Thank you very much, sir. Thank you.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Thank you very much.
Thank you, sir. Thank you.
Thank you, sir.
Thank you.